Welcome to this session of Energy Conservation and Management. Myself, Anirban Sarkar, Assistant Professor in Mechanical Engineering Department of JS College of Engineering, Kalyani, Nadia, in West Bengal. We are discussing about that industrial energy conservations, the various method as we have discussed through the compressor, refractories, various material handling equipments. Today, we are going to be discuss some tips of energy conservations for industries. First of all, in case of boiler, in boiler, preheat combustion air with waste heat is required so as to increase the efficiency of the boiler and save the energy or use the energy of the flue gas to save the extra fuel that required to burn for the preheating of air, etc. It is found that 22 degree centigrade reduction in flue gas temperature increases boiler efficiency by 1%. Second, use variable speed drives on large boiler combustion air fans with variable flow. As we know that the power required depends on and it fluctuates during daytime and depends on season to season. So fuels in the combustion chamber will similarly goes to and it varies. So as the variable speed drives, that is combustion air fan with variable flow required to save the energy. Burn wastes if permitted. The waste from the industrial process and from the household, if permitted by the government and the law, so that we can burn it to gain the energy and thus we can run a boiler. Successful of this burning of waste of industrial and household have been done by in Germany and Singapore and various other countries. It is estimated that 3 tons of waste required in case of if we use 1 ton of high grade fuels. Next is insulate exposed heated oil tanks. So insulation of heated things is required, as we know, for piping system, oil tank, etc., so as to leakage of the convection and radiation heat transfer. Clean burners, nozzle and strainers, because these are all sometimes it is choked and causes the malfunction. So as we need to time we need to clean the burners, nozzles and strainers. Inspect oil heaters for proper oil temperature. So oil heaters are used to cool the certain devices, so that we need to keep that oil temperature which is using as an coolant within the permissible limit. Otherwise, if the temperature raises, so there means there are wasting of heat. That means some malfunctions is there. close burner air and or stock dampers when the burner is off to minimize heat loss up in the stock. Improve oxygen trim control. Example, limit excess air to less than 10% on clean fuels. Automated or optimize boiler blowdown, recover boiler blowdown heat. Use boiler blowdown to help warm the backup boiler. Optimize deaerator venting. Inspect door gasket. So these are all the possible areas where the leakage may take place. That is, heat leakage may take place. Some other areas that we need to be carefully taken care. That is, inspect for scale and sediment in the water side. So in boiler, due to the sedimentation, so continuous blowdown is required. This will cause the extra heat that we need to be sent into the burner or the fuel combustion chamber. So it indicates that a 1 millimeter thick scale on the water side would increase fuel consumption by 5 to 8%. So continuous blowdown process is there to remove the sediment of the feed water in the boiler. Inspect for soot, fly ash and slags on the fire side. That means where from the furnaces where the fly ash, slags, etc. are removed, that part we need to be inspect. If some deposition takes place on that case, so the slag or fly ash will stick to that and it will remain in the furnace, so as it will reduce the efficiency of the furnace. It is found that estimated a 3 millimeter thick soot deposition on the heat transfer surface can cause an increases in fuel consumption to the tune of 2.5%. Optimize boiler water treatment. Add an economizer to preheat boiler feed water using exhaust heat. Recycle steam condense. So in earlier there is an open cycle we are using. So nowadays it is closed cycle. So somewhat we can reuse the condensate. Otherwise it will be costly to make the feed water. Economizers are also there to preheat the feed water to the saturation temperature. Study part load characteristics and cycling cost to determine most efficient mode for operating multiple boilers. These part load characteristics that depends on the nature of the industry or household present and the weather pattern of the country. So this part load, during the part load analysis, it is found that at night 7 to 9 p.m. the most power is required. And in industries, that required during the daytime. And in case of summer and winter, that is also varies. So this part load characteristics is very important, and on which that is most efficiently the how many units will run, that depends. Consider multiple or modular boiler units instead of one or two large boilers. So a higher critical boiler is useful instead of one or two lower critical boilers. Establishes because the in higher critical boiler the efficiency is much higher, and if we go for cogenerations of the from the higher critical boiler one, so ultimately fuel efficiency will be very high. Establish a boiler efficiency maintenance program. Start with an energy audit and follow up, then make a boiler efficiency maintenance program a part of continuous energy management program. Next, that is for steam system. So we always need to fix the steam leaks and condensate leaks. It is found that 3 mm diameter hole if in a pipeline, and if it is carries 7 kg per centimeter square at a pressure, steam would waste 33 kiloliters of fuel oil per year. Accumulate work order for repair of steam leaks that cannot be fixed during the heating session due to system shutdown requirement. Tag each such leaks with a durable tag with a good descriptions. Use backup pressure steam turbines to produce lower steam pressure. Use more efficient steam desulfur-heating method. Ensure process temperature are correctly controlled. Maintain lowest acceptable process steam pressure. Reduce hot water wastage to drain. Remove or blank off all redundant steam piping. Ensure condensate is returned or reused in the process. 6-degree rise, it is found that 6-degree rise in feed water temperature by economizer, either condensate recovery corresponding to, gives 1% savings of fuel in boiler. Preheat boiler feed water. Recover boiler blowdown. Check operating of steam taps. Remove air from indirect steam using equipment. It is found that a 0.25 millimeter thick air film offers the same resistance to heat transfer as a 330 millimeter thick copper wire. So if air is tapped inside the steam lining, so we must remove that one. Generally, in case of riser tube in boiler. Inspect steam taps regularly and repair malfunctioning taps promptly. Consider recovery of vent steam. Use waste steam for water heating. Use an absorption chiller to condense exhaust steam before returning the condensate to the boiler. Use electric pumps instead of steam ejection when cost benefit permits. And establish a steam efficiency maintenance program. Start with an energy audit and follow up, and then make a steam efficiency maintenance program a part of continuous energy management program. Furnaces. The furnaces are very useful. So we need to check the infiltration of outside air. Use doors or air curtains to check the infiltration of the outside cold air into the furnace. So if infiltration is too high, the furnace temperature would be lower. So we need to give more fuels to burn to raise the temperature or to maintain the temperature in the furnace. Monitoring oxygen, carbon dioxide and carbon monoxide level and control excess air to the optimum level. Improve burner design, combustion control and instrumentations. Ensuring that the furnace combustion chamber is under slight positive pressure. Use ceramics fiber in the case of batch operations. Match the load to the furnace capacity. Retrofit with heat recovery device. Investigate cycle times and reduce. Provide temperature controllers. Ensure that flame does not touch with the stove. Insulation, as we have discussed earlier also. So here some also few tips are given. Repair damaged insulation. It is estimated that a bare steam pipe of 150 millimeter diameter and 100-meter length carrying saturated steam at 8 kg per centimeter square would waste 25,000 liter furnace oil in a year. So if due to some damaged insulation, some steam are out of the system, so there is a huge loss. Insulate any hot or cold metal or insulation. Replace wet insulation because it will tends to decay the system, and also it will increase the heat transfer, that is convection and radiations. Use an infrared gun to check for cold wall areas during cold weather or hot wall areas during hot weather. Ensure that all insulated surfaces are cladded with aluminum. Insulate all flanges, valves and coupling. Insulate open tanks. So it is found that 70% heat loss can be reduced by floating a layer of 45 millimeter diameter polypropylene plastic ball on the surface of 90 degrees centigrade hot liquid condensate. So insulation is a very important things in industry. Proper insulation gives us a sound system which is energy efficient. Waste heat recovery, we have discussed elaborately about the waste heat recovery. Here some tips are also given. Recover heat from flue gases, engine cooling water, engine exhaust, low pressure waste steam, drying oven exhaust, boiler blowdown, etc. Recover heat from incinerator of gas. Use waste heat for fuel oil heating, boiler feed water heating, outside air heating, etc. Use chiller waste heat to preheat hot water. Use heat pump. Use absorption refrigeration system. Use thermal wheels, run around system, heat pipe system, and air to air exchangers. Now some electricity distribution system we need to take care. Optimize the tariff structure with utility suppliers. Scheduled operations to maintain a high load factor. Shift loads to off-peak times if possible, because at peak time the energy tariff is highest. Minimize maximum demand by tripping loads through a demand controller. Stagger startup times for equipment with large starting currents to minimize load peaking. Use standby electric generator equipments for on-peak high load periods. Correct power factor to at least 90% under rated load conditions. Relocate transformers close to main loads. Set transformer taps to optimum settings. Disconnect primary power to transform that do not serve any active loads. Consider on-site electric generation or cogeneration. Export power to grid if you have to surplus in your captive generation. Check utility electric meter with your own meter and shut off unnecessary consuming things such as light, computer, printers, etc. at night. Motors as an integral part of any mechanical system. Properly size to the load for optimum efficiency. So if we choose for higher efficiency motors, 4 to 5% higher efficiency than standard motor. So always we have to choose the higher efficiency motor from the rated capacity. Use energy efficient motors when economical. Where economical. Use synchronous motor to improve power factor. Check alignments. Provide proper ventilations. For every 10 degrees centigrade increase in motor operating temperature over recommended peak, the motor life is estimated to be halved. Check for under voltage and over voltage conditions. Balance the three-phase power supply. Demand efficiency restoration after motor removal. Drives. So various drives are available in the industries. So use variable speed drives for large variable loads, because if we go for at constant drives, constant speed drives, so at rated power, suppose some low loads we need to be transferred, then the power consuming is high. So it is preferable to use variable speed drives. Use high efficiency gear set, use precision alignment, check belt tension regularly. Otherwise, if it is slack tension, so it will consume power, and properly the power will not transmit from one pulley to another. Estimate variable pitch pulleys. Use flat belts at alternative to V belts, because V belts, the power ratio of the V belts is higher than the flat belts. Use systematic lubrication for large gearbox. Eliminate eddy current coupling. Shut them off when not needed. Fans. Use smooth, well-rounded air inlet cones for air intakes. Avoid poor flow distribution at the fan inlet. Minimize fan inlet at outlet obstructions. Clean screens, filters, blade regularly. Use all aerofoil shaped fan blades. Minimize fan speed. Use low slip or flat belts. Check belt tension regularly. Eliminate variable pitch pulleys. Use variable speed drives for large variable fan loads. Use energy efficient motors for continuous or near continuous operations. Eliminate leaks in ductwork. Minimize bends in ductwork. Turn fans off when not needed. Blowers. Use smooth, well-rounded air inlet ducts. Minimize blower inlet and outlet obstructions. Clean screens and filter regularly. Minimize blower speed. Use low slip or no slip belts. Check belt tension regularly. Eliminate variable pitch pulleys. Use variable speed drives for large variable blower loads. Use energy efficient motor for continuous or near continuous operation. Eliminate ductwork leaks. Turn blower off when they are not needed. So these are all of the few energy tips of important instruments of the industrial uses. Thank you for joining this session.